Hello everyone. Today I am going to explain you the basics and formulas related to the integration for class 12. First of all, what is integration? In chapter 5 we have learned the method of finding the derivative of a function. Further, there are formulas which help us to reverse the process of a derivative. This process which reverses the process of derivative to find the original function is called antiderivative or integration. Hence, integration is the inverse process of the differentiation. First of all, we have some comparison between the differentiation and integration. First is the both are the operations on the functions. As all functions are not differentiable, similarly all functions are also not integrable. Derivative of a function when it exists is unique. The integral of a function is not so. Any two integrals of a function may be differ by a constant. When a polynomial function is differentiated, the result is a polynomial whose degree is 1 less than the degree of the polynomial. When the polynomial function is integrated, the result of a polynomial whose degree is one more than that of the polynomial. We can speak of the derivative of a derivative at a point. We never speak of the integral at a point. Here in integral we can speak that the integral of a function over an interval. The process of differentiation and integration are reverse of each other. Next is, in order to understand the things clearly, students have to add in their vocabulary some terms related to the integration. This type of symbol in the book or in the notebook represent that integral of a function fx with respect to x. Here fx is called the integrand, x is called the variable of integration. Integrate means find the integral. Constant of integration means any real number c considered as constant of function. There are two type of integrals are there. One is definite and other is indefinite integral. Here in this video we discuss about the indefinite integral. Definition of indefinite integral. The formulas which give antiderivative are called indefinite integral or simply integral. Mathematically, integral of a function is defined as follows. If derivative of this function is this, then integral of this function is this plus c, where c is any real number and is called the constant of integration. Next is integration as the reverse process of a differentiation. This example explains this topic clearly, as the derivative of x square is 2x, derivative of x square plus 1 is also 2x, derivative of x square minus 2 is also 2x, and derivative of x square plus c is also 2x. But antiderivative of 2x is always x square plus c. Why it is c? Because c may be 1, c may be 2, c may be 3, any constant value is to be taken as the c. So when we represent these curves graphically, then we understand what is the difference between these. Graphically, when we represent these, then we see the parabolas. All these equations are the parabolic equations and all are different in the constant value, and there, due to this difference in the constant value, the vertex is moves along the y-axis like this. Next is, what is the major challenge among the students? Major challenge among the students is to how to understand the formula, how to learn the formula, how to implement that formula in the problems. Here we develop a systematical arrangement of the formulas which are easy to understand for the students and easy to learn, so that students can implement that formulas in the problems properly. So first of all, these formulas are called preliminary formulas used for finding the integration, and one by one these are as follows. Integral dx equal to x plus c, integral x dx equal to kx plus c, integral of 0 dx equal to c, integral of x raised to power n dx equal to x raised to power n plus 1 divided by n plus 1 plus c. Integral of 1 over x dx equal to log x plus c. Integral of e raised to x dx equal to ex plus c. Integral of e raised to power ax dx equal to e raised to power ax over a plus c. Integral of a raised to x dx equal to a raised to x divided by log a plus c. Next is important formulas which are used for finding the integration, and these formulas are also we call the special formulas, and these are 9 in type, and we have to write here 3. In all these threes there is no square root in the denominator. Integral dx over a square minus x square equal to 1 over 2a log modulus x plus a over x minus a plus c. Integral of dx divided by x square minus a square equal to 1 over 2a log modulus x minus a over x plus a plus c. Integral of dx divided by x square plus a square equal to 1 over a tan inverse x over a plus c. Next is these are the three formulas in which we have square root in the denominator. So the explanation is like this: integral dx over under root x square minus a square equal to log modulus x plus under root x square minus a square plus c. Next is integral dx over under root x square plus a square equal to log modulus x plus under root x square plus a square plus c. Next is integral dx over under root a square minus x square equal to sin inverse x over a plus c. Next is all these formulas have the square root, but there is no denominator. Integral under root x square minus a square dx equal to x over 2 under root x square minus a square minus a square over 2 log modulus x plus under root x square minus a square plus c. Next is integral under root x square plus a square dx equal to x over 2 under root x square plus a square over 2 log modulus x plus under root x square plus a square plus c. Next is integral under root x square a square minus x square dx equal to x over 2 under root a square minus x square plus a square over 2 sin inverse x over a plus c. These formulas are very important. Student has to learn these special formulas to find the results properly, to understand the implementation of integration properly. And here is one more formula which is also called the shortcut formula, and when the function is given in the exponential form like this: integral e raised to x fx plus f dash x dx equal to e raised to x fx plus c. Student can directly apply this formula if we get the exponential form of the function like this. Next is some shortcut keys. These shortcut formulas can be applied in the problems to increase the speed of solving the problems. First is integral fx raised to power n into f dash x. Here is fx is the first function and f dash x is the derivative of this fx. Then we get integral fx raised to power n plus 1 divided by n plus 1 plus c. Next is integral f dash x over fx. Here numerator is the derivative of denominator. Then we have in this integration equal to log modulus fx plus c. In the next formula we have numerator as the derivative of the denominator, but denominator have some power, like integral f dash x divided by fx raised to n dx equal to fx raised to minus n plus 1 divided by minus n plus 1 plus c. Next is integration of trigonometric functions. Integral of sin x dx equal to minus cos x plus c. Integral of cos x dx equal to sin x plus c. Integral of tan x dx equal to log modulus secant x plus c, or minus log modulus cos x plus c. Integral cot x dx equal to log modulus sin x plus c, or minus log modulus cosecant x plus c. Integral secant x dx equal to log modulus secant x plus tan x plus c. Integral cosecant x dx equal to log modulus cosecant x minus cot x plus c. Integral secant square x dx equal to tan x plus c. Integral cosecant square x dx equal to minus cot x plus c. Integral secant x into tan x dx equal to secant x plus c. Integral cosecant x into cot x dx equal to minus cosecant x plus c. Next is the inverse integration of inverse trigonometric functions. If we have integral of dx over under root 1 minus x square, then this is equal to sine inverse x plus c. Integral of minus 1 over under root 1 minus x square dx equal to cos inverse x plus c. Integral dx over 1 plus x square equal to tan inverse x plus c. Integral minus 1 over 1 plus x square dx equal to cot inverse x plus c. Integral 1 over mod x under root x square minus 1 dx equal to secant inverse x plus c. Integral minus 1 over mod x under root x square minus 1 dx equal to cosecant inverse x plus c. Next is the method of integrations. There are mainly three methods of integration. First is integration by substitution method. Second is integration by using partial fraction, and next is integration by parts. First of all, integration by substitution method. We understand this method by taking one example of finding the integral of tan x. Normally there is the formula which is used for integration of tan x is equal to minus log cos x plus c. But here we find this formula by using the substitution method. Convert tan x into sine over x. Now denominator is cos x. Take cos x equal to t and differentiating on both sides we get minus sin x dx equal to dt. So putting all these values we get integral tan x dx equal to minus integral dt over t, and this is equal to minus log t plus c. Now replacing t by cos x we get minus log cos x plus c. So this is the method of substitution finding the integration. Next is integration by partial fraction. Partial fraction is a method which is used to separate the fractions into a integrable form. This if the fraction is like this, px plus q over x minus a into x minus b, then this can be written as a over x minus a plus b over x minus b. If the fraction is like this, in the denominator there is a square function px plus q divided by x minus a whole square equal to a over x minus a plus b over x minus a whole square. If the fraction is like this, in the denominator is more complicated, then this can be written as a over x minus a plus b over x minus a whole square plus c over x minus b. We divide these fractions into smaller parts. First we write x minus a, then we write x minus a whole square, and then we write x minus b. If the fraction is like this, px square plus qx plus r divided by x minus a into x minus b into x minus c, then this is equal to a over x minus a plus b over x minus b plus c over x minus c. If the fraction is like this, and this is a quadratic equation, and this is x minus a is a linear function, so it can be written as a over x minus a linear, plus if there is a quadratic in the denominator, then we write numerator as bx plus c, so that the difference between numerator and denominator is always remain 1. Here a over x minus a plus bx plus c over x square plus bx plus c. One thing that should be kept in your mind, that while making the applying this partial fraction, there should be a concept related to the power. The power of the numerator is always less than the denominator. If the power of numerator is more than the denominator, then students first they have to divide the numerator by denominator and then apply the partial fraction. Next is integration by parts. Parts integration by parts is the method which is applied when we have two functions in the product form. So in the two functions, we divide these two functions into first function and into second function. The first function, there is a rule for writing the first function. That rule is called the Eilert rule. In the Eilert rule, I means the inverse trigonometric function, L means logarithmic function, A means algebraic or polynomial function, T means trigonometric function, and E means exponential function. And these are given in the increasing order of integration. So it means the inverse trigonometric functions are least integrable, logarithmic functions are more integrable as compared to inverse trigonometric function, and so on. So first function, if there is an inverse trigonometric function, you are given two function in which one function is the inverse trigonometric function, then we take it as the first function. If it is not there, then we take logarithmic function as the first function. If it is not there, then we take algebraic as the first function. If it is not there, then we take trigonometric as the first function. When we select the first function and the second function, then apply the formula like this: integral uv dx equal to u integral v dx minus integral ddx of u integral of v dx into dx, and then solve the problem. Thanks and have a nice day.